Ever wondered how blockchain technology achieves agreement across a network of computers, each potentially acting in their own self-interest? It's a question that gets to the heart of what's known as the consensus problem in blockchain technology. Picture a decentralized network where there's not a single authority to call the shots. Instead, an agreement is required among multiple nodes. This is a bit like a group of friends trying to agree on a movie to watch, except these friends are computers, and the movie is a piece of data or a transaction that needs to be added to the blockchain. But it's not just about reaching an agreement. The consensus mechanism must also be resilient to various types of faults, like nodes going offline or malicious actors trying to disrupt the system. The consensus process must also eventually terminate, meaning that nodes will reach a final decision within a reasonable amount of time. Now, there are several consensus algorithms designed to address these challenges in different ways. Let's explore some of the most prominent ones. First up, we have proof of work, or POW. Famously used by Bitcoin, POW requires nodes to solve complex mathematical puzzles to validate transactions and create new blocks. This process consumes computational resources, making it costly to attack the network. Next, there's proof of stake, or POS. Here, validators are chosen to create new blocks based on the amount of cryptocurrency they hold and are willing to stake as collateral. This reduces energy consumption compared to POW, but still ensures security through economic incentives. Then we have delegated proof of stake, or DPoS, which introduces a democratic element. Token holders vote for a limited number of delegates who are responsible for validating transactions and creating blocks. This can increase transaction throughput but relies on a trusted set of delegates. There's also practical Byzantine fault tolerance, or PBFT. This classical consensus algorithm works well in permissioned blockchain networks. It requires a predefined set of nodes and tolerates a certain number of faulty or malicious nodes to reach agreement. Finally, we have Raft, a consensus algorithm that focuses on simplicity and ease of understanding. It elects a leader node responsible for managing the consensus process and replicating the log of transactions across all nodes. But each consensus algorithm comes with its own trade-offs in terms of security, decentralization, scalability, and efficiency. The choice of consensus mechanism depends on the specific requirements and goals of the blockchain network. So, to recap, the consensus problem in blockchain technology revolves around achieving agreement among a group of nodes on the validity of a certain piece of data or transaction. This involves aspects such as decentralization, fault tolerance, agreement, and termination. Various consensus algorithms have been developed to address these challenges, each with its own strengths and weaknesses. The choice of consensus mechanism ultimately depends on the specific needs of the blockchain network.